Imagine you are on board a spaceship. The captain speaks the magic words, full warp drive. A low hum is heard and off you go. The science fiction fans among us are familiar with these scenes from TV series and films. The stars flash brightly once more, then the spaceship disappears into the vastness of the universe. But seriously, what would we actually see at the speed of light? What would pass you by if you could look out of the window while traveling at the speed of light? And most importantly, what would happen to your body if it moved through space that fast? You probably know that light is very fast. It travels at an incredible speed of about 299,792,458 meters per second, and nothing we know of travels faster than light. When the spaceship accelerates to high speeds, the light coming from the stars is initially affected in a very special way. The stars would behave differently depending on whether your spaceship is traveling towards them or away from them. The light from the stars you are moving away from would be shifted towards the red end of the light spectrum, which is called a red shift. This red shift occurs because the spaceship is moving away from the star's light, shifting the light into longer wavelengths and the corresponding red hues. The stars behind you would therefore become increasingly blurred and red. The light of the stars you are racing towards, on the other hand, would be shifted towards the blue color spectrum. This happens because your spaceship is moving towards the light of the star, which shifts the light to shorter wavelengths. In physics, this is called the Doppler effect, and in practice, astronomers use this effect to determine the speed and distance of stars and galaxies in the universe. There are no stars. Let's move on to another exciting phenomenon of your space journey. The Doppler effect is not quite right. If you were sitting in your spaceship and looking outside, you probably wouldn't see any stars at all, and there's a simple reason for that. All astronauts who have been to the cosmos or the moon have reported that there are no stars in the universe. We usually think that the star sky in space should be much brighter and more beautiful than here on Earth, and then you are in the universe, and the stars are gone. There are two reasons for this effect. In the weightlessness of space, you are floating in a vacuum with no atmosphere or air to scatter the sunlight. On Earth, the atmosphere scatters the light from the sun and stars, making the sky appear blue during the day and dotted with stars at night. But in space, far away from Earth, there is no such scattering of light. This means that the light from the stars reaches you directly from the stars without being scattered. This may sound great at first, but there is a catch. The light from the stars is very weak, and if you are close to the sun, our sun would intensify this effect. Your eyes wouldn't be able to see what little light there is, and the sunlight is so bright that it outshines the faint starlight. Scientists suspect that this effect would even occur when traveling between star systems. Again, it would be the vacuum of space that prevents the light from the stars from being scattered. Only when you get closer to the next star system and the particle density increases would you see light again. This is strange, isn't it? Because we know from movies and television depictions in which the universe is full of bright stars as seen from spaceships. On your journey through space, however, you would encounter even more strange things that you certainly didn't expect. You are young, and everyone else has aged. You may think that time is the same all over the world, but that's not necessarily true. According to Einstein's special theory of relativity, time slows down when you move at a high speed. This means that if you take a long journey through space at high speed, time will pass more slowly in your spaceship than for people on Earth. That really sounds like something out of a science fiction movie, doesn't it? Assuming you fly through space at very high speed for 3 years and then return to Earth, it would feel to you as if only 3 years had passed. You would have aged 3 years in that time, and you would remember the travel time of 3 years. But here's the fascinating part. According to Einstein's laws, more time has passed during your space travel. So you would come back to a world where friends and family have aged much more than you have, and for these people, much more has happened. This phenomenon is called time dilation, and it shows how strange and fascinating time can be in different situations in the universe. Time is a quantity of physics that still poses some mysteries. We do not know how it behaves in the other parts of the universe and whether there are ways to circumvent or control it. Timeless travel with the warp drive? Einstein's laws have even more pitfalls because nothing can actually travel faster than light. No matter with a rest mass can even come close to the speed of light. Whether we will ever be able to travel at the speed of light is therefore questionable. But we may be able to travel much faster and easier with a trick. Researchers have adopted the idea of warping space from science fiction literature. The spaceship does not move through space but rather bends space and itself a little, and then slips through a hole in the spacetime structure, and you would be anywhere in the universe in a flash. Sounds crazy, but we won't be able to manage interstellar travel any other way. Because even at the speed of light, it would still take us more than 3 years to get to the next star system, Alpha Centauri. So if we want to explore space, we need faster-than-light speed or the warp trick. What you would see on board a warp spaceship when it slips through folded spacetime is a mystery. Nobody can imagine it yet. You would probably only see darkness until the light of the targeted star system came into range. What happens to the body? We take a short journey back in time to the year 2150. Unfortunately, warp drive has not yet been achieved. But thanks to the revolutionary technologies and the discovery of a new energy source material, spaceships capable of reaching the speed of light have been developed. The first crew to travel at the speed of light consisted of 5 astronauts who embarked on a mission to explore a distant solar system. However, they soon realized that this type of journey had some effects on their bodies. The journey began innocently enough. As the spaceship accelerated to reach the speed of light, the crew felt as if they were sinking into a deep sleep, even though they were awake. This was a kind of side effect of the flight, and the sleep was also intended to protect the crew from the psychological stress of the extreme speed. Once they reached the speed of light, the physical effects began to show. The astronauts noticed that their bodies were shrinking as if they were suddenly getting younger. This was due to time dilation, which we have already looked at. The gravitational forces acting on the crew during the flight were also not without consequences. With constant acceleration, the astronauts were pressed more and more onto the floor of their spaceship as their speed increased. This led to muscular atrophy and bone loss. As the journey progressed, the astronauts found it difficult to tell the time as their clocks were running faster and faster compared to time on Earth. They could not be sure how long they had been traveling or how long they had been absent on Earth. The crew became completely disoriented, but luckily the spaceship was flying with automatic controls. Eventually, the crew reached their destination, a distant solar system, and assuming these 5 brave space travelers survived the ordeal, they made some amazing scientific discoveries at their destination. When they returned to Earth after another ordeal of faster-than-light space travel, they realized that many decades had passed while only a few years had passed for them. This clearly shows that the matter of the speed of light will very probably not work out with regard to our bodies either. But what other options do we have for traveling through space? When will we be able to teleport? The idea that humans could use teleportation to travel through space is another fascinating concept that often appears in science fiction. The process is usually called beaming. When matter is teleported, it is disintegrated, transported to another location, and reassembled there. However, there are some major challenges and physical laws that make such ideas difficult. Theoretically, an object made of matter can be reduced to its information. The evidence for this has already been provided by quantum mechanics. Based on the information, the object could theoretically be reconstructed at a different location. However, the greatest challenge on a purely mathematical level is the exact replication of a human being or a spaceship on an atomic level in order to recreate it in another location. This requires an incredible amount of data and the ability to capture the entire complex structure of a human being and reconstruct it in another location. Of course, there are still some aspects of biology that speak against this. What happens to the matter, the blood, the organs, and above all, how is all this recreated at the destination? We are reconstructing a UFO. If we believe the many thousands of UFO sightings that have been reported in the last 100 years alone, these flying objects have long since transcended the laws of physics as we know them. They move in a way that contradicts the laws of Newtonian physics, dynamics, and acceleration. Pilots report flying saucers that navigate in a crisscross and very quickly through space, while others can allegedly take off almost vertically from the ground. It's also striking that none of the UFOs reported so far have had a visible drive like our airplanes, for example. Some rotate on their own axis, and others are described as having something like wheels that move in all directions simultaneously. So it looks like we still have a lot to learn about space travel. But whether and when aliens will give us a lesson in building spaceships is an